This video was produced by
Another common measurement that you may need to make with a multimeter is to measure the resistance of an element. To measure the resistance of an element, we also need to be concerned with the lead placement. To make the resistance measurements, again we're going to put the black lead into the common input port. For resistance measurements, the other lead is going to go for the 179 meter right above the common input port, and that's indicated by this ohm symbol, or the omega, right there. As well as for the Fluke 115, it's going to go on the right-hand side port. So for measuring voltages as well as resistances, the lead configuration is the same. To measure the resistance, we need to set the meters to the correct dial position for measuring resistance, and that's indicated by the ohm symbol yet again, or the omega. So we're going to turn the dial, the setting dial, to that omega symbol. Now to make the resistance measurements, all we're going to do is need to attach the test leads to either side of the resistance element that's under test. So here's a resistor, and I'm going to attach my test lead to either end of the resistance. And in this case, we're measuring a resistance of 6.78 kilo ohms. I'm going to move over to this resistor, and we will find that we're measuring about 0.4 ohms of resistance with this element. Some important things to keep in mind when you're measuring resistance. First of all, you should always try to take the resistive element out of the circuit that you're trying to find the resistance of. Also, you need to make sure that any power supplies, any voltages or currents that are moving through the system, those power supplies need to be disabled. If it's not out of the circuit or the power supplies are not disabled, you will definitely get an inaccurate reading of the resistance of that element. And that's because series and parallel resistances in the circuit, including the power supply, can affect that measurement. Another thing to keep in mind, especially when using the 115 meter that does not have the nice clip leads on it, is that when you measure resistance, you want to make sure that you yourself are not physically touching the test leads. So to measure a resistance with the 115 meter, what you need to do is make a good solid contact between the test leads, or between the leads of the resistor and the test leads, but without touching the test leads themselves. If you try to do something like this and hold it on, you may get inaccurate results because your body has some resistance to it as well. So again, we do not want to hold the test leads on with our thumbs or anything like that. We want to lay the element down on some non-conducting surface and make sure we get a good contact there. So in this case, I've measured 6.77 kilo ohms using this method, whereas when I touch them with my fingers, because of my body resistance here, I measure something about 6.1 kilo ohms of resistance. Finally, a measurement that is related to resistance measurement is that of continuity. Continuity check can be performed by moving our dial to this little sound symbol. It has a few curved lines. It looks like something coming out of a speaker. And what continuity does is it basically checks the resistance of between 2 points. What happens is that the meter will emit a beep when there is electrical continuity between 2 points in a circuit. So on the 115, if I touch the two leads together, there should be low resistance between them, and we get a nice beep noise out of the instrument. Same thing will happen with the 179 meter. This is particularly useful when trying to troubleshoot circuits to make sure that there's an electrical connection between all of the elements, as well as when you're working with breadboard circuits. Oftentimes it's difficult to know when you're working with a breadboard circuit like this which slots of the breadboards are electrically connected with each other. And a very quick way to test it is to use the continuity meter settings on the digital multimeter. So we find that by measuring effectively the resistance, we get an audible indication, a very quick indication that these two elements are connected to each other, whereas these two are not. Both of these meters operate in a similar fashion and make similar measurements. The primary difference between them is the range of operation and how accurately they can measure the various parameters. So when in doubt, what you need to do is you need to look at the manuals, the operation manuals for the instruments to determine what their accuracy limits are and what their range of operations are. There are a number of other measurements that can be made with the multimeters that we're not discussing here. If you have questions about how to make those measurements or you need to make those measurements, again, I suggest that you consult the manual as well as the TA or the instructor for the course.